This is 4-5, triangle congruence, SSS and SAS. Let's take a look at the warm-up. Name the angle formed by ray AB and ray AC. Remember that A is the end point because it was the first letter in the ray. So to name this angle, we could call it angle A, we could call it angle BAC, keeping A the vertex in the middle, or we can call it angle CAB. Name the three sides of triangle ABC. Notice I'm always drawing an image to help me with this, but the sides, there'd be three sides of a triangle, so it'd be segment AB, segment BC, and segment CA. Triangle QRS is congruent to triangle LMN. Name all pairs of congruent corresponding parts. So if we draw this out, we've got QRS, LMN in the same order. Q has to match L. R needs to be congruent to M, so give that one 2 marks. And N needs to be congruent to S, according to the location of these congruent symbols. And in addition, QR is in between 1 and 2, and so I'll put the tick mark in between L and M, put angles 1 and 2, arc marks there. Let's put 2 in between this one and 3 here. So this makes it a lot easier to name each thing. So each congruent angle first, angle L is congruent to angle Q. Angle M is congruent to angle R. Angle N is congruent to angle S. And then from there, side lengths, we've got segment QR is congruent to segment LM. Segment MN is congruent to segment RS. Making sure I'm going in the same order. And if I say NL, then I have to say SQ. So segment NL is congruent to segment SQ. So before we could determine that two triangles are congruent if they had all the parts congruent. All angles are congruent and all sides are congruent. Triangle rigidity gives us a shortcut for proving that two triangles are congruent. So right here, triangle rigidity gives us a shortcut for proving two triangles are congruent. It states that if the side lengths of a triangle are given, then the triangle can have if the side lengths of a triangle are given, the triangle can have only one shape. So our first shortcut is SSS. If we know that all three sides of one triangle are congruent to all three sides of the other, then we know that the triangles are congruent. And therefore, after we know that they're congruent, we could then say, like, angle A is now congruent to angle F, or angle B is now congruent to angle D, which is in a later chapter. But I want you to understand that we can state, without knowing the angle measures, we can actually know for sure that these triangles are congruent by the shortcut, SSS. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Okay, let's look at our first proof here, using SSS to prove triangle congruence. Use SSS to explain why triangle ABC is congruent to triangle DBC. So triangle ABC, let me highlight it. We're trying to prove that this triangle is congruent to DBC, this triangle. So let's see what we're given first. So looking at my tick marks, I know that I was given that side AB is congruent to side DB. I was also given that side AC, based on these tick marks right here, that AC is congruent to DC. For the reflexive property of congruence, what that is saying is that when something is the same thing as itself, so for instance, side BC, is it congruent to the other side BC? It has to be because it's the same thing. So let me separate these triangles so you can see what I'm talking about. This is ACB and this is BCD. Now we were given that AB was congruent to BD, and we were also given that AC is congruent to DC, but do we know if these two sides, BC and that BC, are congruent? Well, they have to be because they are the same. That's what reflexive property of congruence says. So now we're finally able to prove that triangle ABC is congruent to triangle DBC by SSS, because we know all three sides are congruent. This reflexive property of congruence is going to come up a lot in these theorems. Next, we need to know about an included angle. An included angle is an angle formed by two adjacent sides of a polygon. So if we have like ray AB and ray BC, for instance, the included angle is angle B, shown in the image here. Angle B would be the included angle. It's in between these two sides. So when we talk about side angle side in a minute, what we're talking about is we would need one side congruent to another triangle side. We would need the included angle and another side. So it's like once you start along this little track here, it would continue. Okay, it'll make sense as we do more problems. So side angle side, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So this is our next shortcut. SAS, SAS, side angle side. Use SAS to prove two triangles are congruent. So take a look at what we already know. Usually for our proof we have statements and reasons. So the first thing that we already know is that side XZ is congruent to side VZ. It's shown by that red congruent tick mark. That was given. Another thing that we know is YZ is congruent to WZ. That was given. So I have a side and a side. So we either need another side, which I don't know anything about WV and XY, so that's out. So I'm not using side, side, side. Or I need an included angle. The included angle would have to be in between these two sides, this angle. Do we know anything about those angles? We actually do. Angle, I can't call it angle Z because there's two of them. I can call it angle XZY is congruent to angle VZW because of vertical angles, vertical angle theorem. Can you just take a quick look at why I said X to Z to Y, and on the next one I started at V? Well, side XZ came first in my last description, my last angle measure, so that's what I'm doing again. I'm using that one congruent tick mark first. So VZ to W. Okay? So now we have our side angle side. So now I can say that the two triangles are congruent. So I'm going to be careful how I say these two triangles. Like if I redrew this, X, Z, Y, then I know that V would be right here because XZ is supposed to match VZ. They have the same tick mark. So it's going to go VZW. Triangle XZY is congruent to triangle VZW by SAS. Okay, example 3, verifying that triangles are congruent. Show that the triangles are congruent for the given value of the variable. Triangle MNO, so M to N to O, is congruent to triangle P to Q to R. So we're saying that MN should be congruent to PQ according to the congruent statement. So if I want to, I can redraw these triangles so they actually match. So M was supposed to go with P, and Q goes with the N. So I already know this PQ that matches the side 7 should be X plus 2, right? And the QR, which is right here, is X, and the PR, according to my image on the right, is 3X minus 9. So I've just redrawn this so that my two triangles actually are matched up now. Some people don't have to redraw that. They can see it automatically. But we're saying that when x is 5, we're trying to prove these triangles are congruent. So if I replace x with a 5, are the triangles congruent? Like 5 plus 2, we get 7. The 5 matches the 5. And 3 times 5, lost the 3 there. 3 times 5 is 15 minus 9, which is 6. And that's what we needed to match right here. So yes, these are congruent. And I can just show that by plugging in the x. Triangle STU is congruent to triangle VWX. So S is supposed to match V. So if you look at the lineup right now, that's pretty close. Let's check T is supposed to be with W. T is here. And W is up here. So it's sort of like a reflection. We would kind of need to flip this triangle down if we want to line everything up. So if I put W down here and V where it should be in X, then I can just rewrite what was on the right. So WV is 11. Almost put that in the wrong spot. WX is 7. And angle W is 92 degrees. So I just took everything that was on the triangle on the right and I just moved it over to show what's going to match up with what. All right, so for instance, when y equals 4 now, well, if I plug in 4 into my y position, like here, 4 plus 3, well, that got me 7. So that matches. 2 times 4 plus 3, that's 8 plus 3, which is 11, and that matches. And if I plug in 4 in here, that's 80 plus 12, which is 92, and that matches. So these are congruent.